Hi everyone, welcome to another video of this channel. So today I will be sharing with you problem 11 from the 2024 AIME, which was recently, and I'm going to be sharing you the solution I used on the actual exam. So we have this regular octagon. Each vertex is colored either blue or red. We have to rotate this octagon so that all the blue vertices land on spots previously occupied by red vertices, and we want to find the probability of having a configuration that we can rotate in such a way. So whenever we have these questions, right, where there's a lot of potential cases and the numbers can potentially get big, first demonstrate it on a small example, right? So here, let's just randomly color the vertices blue or red, and let's try rotating this octagon so that the blue vertices land on the red vertices. Well, in this example, we pretty obviously can't because there's more blue vertices than red vertices. At least one blue vertex is going to land on a blue vertex, right? So this is clearly not in our favorable outcomes, right, for this problem. But what if there's four blue vertices, three blue vertices, two, one, or zero blue vertices, right? If there's less than five blue vertices, this problem actually becomes interesting. So first of all, there's going to be 2 to the 8th, which is 256, total possibilities, right? Total colorings. And we're going to perform casework, right? So first of all, if there are no blue, right? If there are all red, obviously this case works. Therefore, we have one favorable configuration from this case. What if there's exactly one blue vertex? Well, this case works no matter where the blue vertex is, no matter how we rotate it, it's always going to end up on a spot occupied by a red vertex, except if we rotate it by a full 360 degrees. Therefore, we're going to get 8 from this case. And now we have the two blue vertices case. If we have two blue vertices, obviously if they're together, just a simple rotation by 90 degrees to the right will work. If they're apart, we can rotate by 45 degrees this way, and this is going to work. Therefore, we get 8 choose 2, which is 28 from this case. So all the two blue vertices cases work. What about the three blue vertices? So let's suppose all three of them are together. Obviously, a 180-degree rotation will work. If all three of them are separated, like this, let's say, in this case, we're going to have a 45-degree rotation this way, which is going to work. And then this way, we just rotate it by a full 180 so that this vertex gets mapped here, this one gets mapped here, and this one gets mapped here. And all of these new vertices were previously occupied by red vertices, and therefore the all three vertices separate case will work. What about if two of them are together and one is apart? Well, in this case, we can just rotate by 180 degrees, and this will work. And if we place this one right here, this time a 180 degrees rotation will not work because these two vertices are opposites. However, we can rotate 90 degrees this way, and this will work. So these are all of the unique three blue vertices cases. Therefore, there's going to be exactly 8 choose 3, which is equal to 56 more favorable configurations. Now, we already know that everything with 5 or more blue vertices doesn't work, but what about with 4 blue vertices? So if we have 4 blue vertices, first of all, there's this case where all of them are together, right? In that case, we just rotate by 180 degrees. So all of the configurations in that case will work. There are 8 total such configurations. So that's another 8 favorable configurations. Next is the case where 3 of them are going to be together and 1 is going to be apart. And here is where it actually gets interesting because it turns out that this case does not work. So if we put the apart vertex over here, then the only place where the three vertices can be rotated to is here. So this will have to be rotated like this, a full 135-degree rotation, but then this vertex right here will land over here, which is a blue vertex. Therefore, this case right here will not work. And we can also test the other case. If the dot is here, if the blue vertex is here, then there are no spots of consecutive red vertices for the consecutive blue vertices to be placed on, and therefore this case does not work as well. Therefore, the three together case does not work. What about the two together case? What if we have two consecutive blue vertices and then two vertices that are not together? So let's say the first one starts right here and the second one starts right here. Well, this case clearly does not work because, again, we run into the same issue. We have to rotate this pair of blue vertices, this consecutive pair of blue vertices, 90 degrees to the left. But if we do this, then this vertex will land over here. So the vertices that are apart will interfere, and therefore this case does not work. Now the question remains, what if both blue vertices are over here, right? And this actually will work if we rotate by a full 180 degrees. And there's exactly 8 such configurations. Therefore, we already get 8 from this case. And these are the only two cases that have 2 together and 2 apart. But what if we also have a case where 2 of them are going to be together, right? What if we have this? So 2 pairs of 2 vertices along the same edge. Well, this of course works, just rotate by 90 degrees. And there's going to be exactly 4 such combinations, not 8 because there's symmetry. So that's another 4 favorable configurations. And of course, if we have the second pair of connected vertices here, this will not work because the blue vertices will interfere with the rotation. All right, so this is it for the 2 together case. Now, finally, we have the case where all of them are apart. And here there's exactly 2 cases, right? 2 unique cases by rotational symmetry, like this. And here just a simple rotation by 45 degrees will do. And similarly for this case, right? The other case. So both of these cases will work. And therefore, what we get from the 4 blue vertices case is a grand total of 8 plus 8 plus 4 plus 2 favorable configurations, which is equal to 22 favorable configurations. All right, so to find the total probability, we have 1 plus 8 plus 28 plus 56 plus 22 over 256. This is going to be equal to 115 256. This is the AIME. Of course, the answer is an integer, and therefore the final answer to this problem is 371. All right, so I hope you enjoyed this video. Thank you for watching, and I'll see you next time.